Hello, this is the answer key to the mole review that was distributed in class, and completing this mole review will gain 2 extra credit points on the test, this unit. So to start this review video, questions 1 through 6 all ask you to calculate the molar mass. To determine the molar mass, one of the important pieces in the mass of a single mole. So this is a compound. Hydrogen is a compound of 2 individual hydrogen atoms. So you have 2 atoms that each are 1.01 grams per mole. So the molar mass of hydrogen molecules is 2.02, and the units for molar mass must include grams per mole. Okay, the second question is iron 3 hydroxide. This 3 indicates that the charge on iron would have been the +3, so the name iron 3 hydroxide is for the compound Fe parentheses OH close parentheses 3. So you have 5. If you look up iron, 55.85, and there is only 1 of them. Oxygen, there are 3 of them. Because this little 3 is on the outside of the parentheses, it applies to everything that's inside the parentheses. So this 3 goes to both the oxygen and to the hydrogen. So there are 3 oxygens, and each oxygen has a mass of 16, and there are 3 hydrogens. And if you looked up the periodic table's average atomic mass for hydrogen is 1.01. So then you need a calculator, and you are going to add 55.85 plus 3 times 16, so plus 48, plus 3.03, and the total mass for iron 3 hydroxide is 106.88 grams per mole. Okay, and then you will do the same thing for phosphoric acid, which is H3PO4. There are 3 hydrogens. In phosphorus, we have a mass of 30.97, and there are 4 oxygens. So you need to multiply 4 times 16. So if you add the mass of these 3 separate elements together, the overall molar mass of phosphoric acid is 98.00, and the units are important, so you need to include the grams per mole. Okay, the next question is ammonium sulfate. So nitrogen has a molar mass of 14.01, but there are 2 of them because this 2 applies to everything in the parentheses. And then separately, hydrogen is 1.01, but there are 8 of them because there are 4 hydrogens in ammonium, but there are 2 ammoniums. So in total, you have 8 hydrogens. All right, and then sulfur is 32.07, and oxygen is 16.00, but there are 4 of them. So you need to add each of these separate elements. Almost done. So the total molar mass is 132.17 grams per mole. Question 5 asks you for C3H6O. So in carbon, there are 3 of them, and carbon has a molar mass of 12.01. There are 6 hydrogens, and there is only 1 oxygen. So in total, the molar mass of this chemical is 58.09. Do not forget units, grams per mole. Okay, the last question is H2S. So there are 2 hydrogens at 1.01 each. There is 1 sulfur at 32.07. So the molar mass for this entire compound is 34.09 grams per mole. So these 6 questions asking you to calculate molar mass, they all are calculated the same way. You look up these values from the periodic table, you multiply it by how many there are, and then you add all of the separate masses together to get a total molar mass for one single compound. Okay, this is a fundamental step for this unit. If you have trouble with this, make sure you seek help before the test. Okay, the next couple questions ask you to convert the following 2 moles. So you're going to need the molar mass that we just learned how to calculate or just demonstrated how to calculate in 1 through 6. So every time it is asking you to do a conversion, what you are really doing is some type of dimensional analysis problem. And there are 3 steps. The first step is to always figure out what is the pathway. And this question asks you to convert molecules to moles. So be careful with the abbreviation for the word molecules. You cannot use MOL because MOL stands for moles. So if you're going to convert molecules to moles, you need an equality. And so you need a number that makes molecules and moles equal. And so this actually does not use molar mass. This uses Avogadro's number. So if you have a single mole, that means that you're going to have that huge number of molecules. All right, so that's 6.022 times 10 to the 23rd molecules are equal to 1 mole. The third step is to set up the units set up the multiplication so that the units cancel. So since we are converting 1.50 times 10 to the 24th molecules into moles, we need the abbreviation for molecules to be on the bottom so that this molecule will cancel out with that molecule. Well, since this is the equality, since these number of molecules equal 1 mole, then if the molecules are on the bottom, the 1 goes on the top. So from here, you use your calculator, 1.4 times 10 to the 24th, and you divide it by 6.022 times 10 to the 23rd. So the most common mistake for people in entering it into the calculator is that they don't use parentheses. So it's important that you enter it into your calculator correctly so that it will follow the correct order of operations. But when you do this, 1.5 times 10 to the 24th divided by 6.022 times 10 to the 23rd, you should get a number using correct number of significant figures of 2.32. And the only units that remain are MOL, so that is your final answer with units, 2.32 moles. Okay, question 8 is a different pathway. All of these questions ask you to convert 2 moles, but this one is going from grams to moles. This is the case where you need a certain number of grams or equal to a certain number of moles. And in 1 mole, you have to consider how many grams of potassium, oxygen, and hydrogen would make up 1 mole. So potassium is 30.1 or 39.1. Let's look at the periodic table. 10. 39.10. Oxygen is 16. And hydrogen is 1.01. So when you add all these together, the molar mass of potassium hydroxide altogether is 56.11 grams per mole. So the number that makes these two this conversion factor equal is 1 mole of potassium hydroxide is 56.11 grams of potassium hydroxide. So in the third case, all you do is set up this multiplication problem so that the units cancel. If the number you start with is 5.96 grams of KOH, you need to set up this conversion factor in a way that allows the units to cancel. So 5.96 grams can cancel with 56.11 grams. So 5.96 divided by 56.11. And since the number at the beginning of the problem has 3 significant figures, your answer should round to the 3rd significant figure. And after grams cancel, the only units that remain are moles. So those should be the units in your answer. Okay, question 9 is the same pathway we just completed. The pathway is asking you to change grams of something into moles, grams to moles. Okay, so you need an equality that relates the grams of calcium acetate into the number of moles. And we want 1 mole. So calcium by itself has a molar mass of 40.08. 40.08 grams. Now, this next part can be a little tricky because you've got numbers, you got subscripts inside the parentheses and subscripts outside the parentheses. But apply this subscript correctly to get the fact that there are 4 carbons. There are 6 hydrogens, and there are 4 oxygens. So 40.08 plus 12.01 times 4 plus 6.06 times 1.01 plus 4 times 16 is 64. So in total, calcium acetate has a molar mass of 158.18 grams per mole. So these are the units for molar mass. So the conversion factor is that there are 158.18 grams equal to 1 mole. So the third step of any dimensional analysis problem is to set up the units, set up the multiplication so that the units cancel. So the problem starts with 937 grams, put that over 1, and now you can use this conversion factor to cancel units. So the 158.18 grams should go on the bottom. The 1 mole goes on the top. And so you can demonstrate that grams cancel. 937 divided by 158.18 is, to 3 significant figures, 5.92 moles. The last question on the front side is now changing. It has a different pathway. This is atoms to moles. So these are types of particles. So you need the Avogadro number. How many atoms are equal to a certain number of moles? And if you have 1 mole, you're going to use Avogadro's number. Okay, so there are this many atoms in 1 mole. The third step of any dimensional analysis problem is to set up the multiplication so that the units cancel. So we're starting with 1.2 times 10 to the 23rd atoms. And we want to convert into moles. So you need to ensure that the atoms goes in the denominator. And you have the 1 mole in the numerator. In this way, the atoms will cancel, and so you are left with 1.2 times 10 to the 23rd divided by 6.022 times 10 to the 23rd, which is a number of moles. So 0.19926. This number only has 2 significant figures in the problem, so you have to round based on the second significant figure. So your final answer should be 0.20 moles. So that's it for the front side. The information you need is a periodic table. So you need to reference the average atomic mass to use the periodic table and look up each of the separate pieces. So iron is 55.8. Here's potassium, 39.098 would round to 39. Look up the periodic table's mass again. So we've already done this one, but 55. So here's argon, 39.95. The backside of this problem now is asking you to get to particles. So this is asking you for how many atoms or molecules or formula units, depending on the type of matter we're dealing with. Okay, so in this case, in number 11, it asks you to go from moles of this substance. So we're going moles, and we got to get to particles. And since we're using barium chloride, this chemical right here has a metal in barium and a nonmetal in chlorine. So it's a metal with a nonmetal. That means that the formula is an ionic compound, and the name for the particles of ionic compounds are formula units. So question 11 is asking you to change 2.39 moles of barium chloride into formula units. So from here, you need an equality. How many moles equal how many formula units? So 1 mole is 6.022 times 10 to the 23rd. The third step of any dimensional analysis problem is to set up the multiplication so that the units cancel. That means you have to write the units. A lot of people skip this step right here, but if you're going to show that the units are canceling, they need to be present in your problem. So in this way, you can see that the mole has to go on the bottom, which puts the big Avogadro number on the top, and we are converting into formula units. So 2.39 times 6.022 times 10 to the 23rd converts moles into formula units. So the final answer should have 3 significant figures. On your calculator, it looks like something like this, times 10 to the 24th. But we have to round based on this digit. So the 1.439 ends up rounding to 1.44 times 10 to the 24th formula units. In question 12, it is asking you to change to particles. So we are going again from moles to particles. But now this time, we're using the matter of H2O. All of these atoms are nonmetals, which means that they must be bonded in a covalent bond. That means that the name of the particle are molecules. Okay, so if you are looking for a relationship between moles and molecules, you're going to use Avogadro's number again. So in 1 mole, there are 6.022 times 10 to the 23rd molecules. So when you set this problem up so that the units cancel, you put the mole over 1, the moles that you start with, so 0.2 moles over 1 times the number of molecules. All of that is divided by 1 mole. In this way, you can see that the units are set up in a way so that they cancel. So 0.2 times 6.022 times 10 to the 23rd is 1.20 times 10 to the 23rd molecules. So it's important that you end with units. So anytime you have a number without a unit, that answer is incomplete. Question 13 asks you to convert grams into particles of iron 3 oxide. Since these are particles of iron 3 oxide, iron is a metal and oxygen is a nonmetal. That means that these particles are ionic compounds. So the particle that we're looking for are formula units. So in the question, it's asking you to change the following into particles. We have grams of a substance, and we are trying to get to formula units. But you can't go straight from grams to particles. There is a middle step. So in this case, you have to go from grams to moles, and then from moles, you can go to formula units. So this is the big step. Anytime you have mass of a substance and you are trying to get to particles, the mole is the step in the middle. So after you have figured out the pathway, the second step of any dimensional analysis question are to find the equalities. So in this case, we need to know how many grams are equal to how many moles of iron 3 oxide. And then separately, you need this one. How many moles are equal to how many formula units? So there's 1 mole of each of those things. And so you need the molar mass of iron 3 oxide. So iron, if you 8.5, and there are 2 of them, and oxygen is 16, but there are 3 of them. So 16 times 3 plus 55.85 times 2 in total, the molar mass is 159.70 grams per mole. So that means that there are 159.70 grams are equal to 1 mole. So this is the equality for this conversion. The second equality is asking us to go from moles to formula units, and in this case, we're going to use Avogadro's number. So moles to particles uses Avogadro's number. That's 6.022 times 10 to the 23rd. All right, so the third step of any dimensional analysis problem is to set up the units, set up the multiplication so that the units cancel. So we are starting with the number 8.35 grams. 8.35, so this is step C. 8.35 grams of iron 3 oxide, put it over 1. And we already established that there are 159.70 grams are equal to 1 mole. And to convert moles to formula units, we're going to use Avogadro's number. Formula units. Okay, so after you have this problem set up in a way where the units will cancel, in order to do the order of operations correctly, you should multiply across the top. So I have across the top equals 5.02837 times 10 to the 24th. And then you divide by the bottom, 159.7. The final answer after you divide the top by the bottom gives you a number on the calculator, 3.1486 times 10 to the 22nd. Because the number we start with has 3 significant figures, we have to round our final answer to the 3rd significant figure. So this 4 is followed by an 8, which rounds up to 3.15 times 10 to the 22nd formula units. Okay, so that's the end of questions 11 through 13. The last 3 questions all have the same instructions. They're asking you to convert a substance in moles, or this is particles, and this is also particles. It's asking you to convert to grams. So, question 14, the pathway that's presented is moles to grams. To do this conversion, you're wondering how many moles are equal to how many grams. Anytime you have this conversion factor, you need the periodic. So 1 mole of argon is 39.95 grams. So the third step of any dimensional analysis problem is to set up the multiplication so that the units cancel. So 6.14 moles is going to be multiplied by 39.95 grams. In this way, your moles in the numerator will cancel with these moles of the denominator. So 39.94 times 6.14 gives you an answer of 245.2316, and we have 3 significant figures in our problem, so 245 grams. Okay, question 15 gives you atoms and asks you for grams. So that's particles. Atoms of aluminum are particles of aluminum. So you are starting with atoms, and it is asking for grams. But you can't go straight from particles to grams. You have to go to the middle step of the mole. Okay, so you can't go straight from atoms to grams. You need these 2 separate conversions. So the first conversion is atoms to moles. So atoms are a type of particle. That's going to require Avogadro's number. So 6.022 times 10 to the 23rd atoms are equal to 1 mole. Oh, and then the next conversion is moles to grams. If you're trying to get mass, you need the number from the periodic table. So moles is equal to a certain number of grams. So if you have 1 mole of aluminum, if you were to look up on the periodic table, that's 26.98 grams of aluminum. All right, and then the third and final step of converting atoms of aluminum into grams of aluminum is to set up the multiplication so that the units cancel. 2.45 times 10 to the 24th atoms. So again, you have to list the units. If you want to show the units canceling, you've got to show the units. So the first step asks you to go to moles. So we will cancel off atoms. After you have demonstrated that atoms cancel, you're going to change moles into grams. So the moles will cancel. You end up adding the molar mass, 26.98. So 26.98 times 1 times 2.45 times 10 to the 24th is 6.6101 times 10 to the 25th. And now, a lot of people make this mistake. You need to include units. You need to include parentheses when you divide by a number in scientific notation. So if you are not careful with the parentheses in your calculator does not understand the correct order of operations. So if you correctly use parentheses, you're going to get a number that's 109.765. But since the number that we started with in the problem has only 3 significant figures, these 3 digits have to be rounded to the 3rd significant figure, and this actually causes that number to round up. So the number of 110 looks like it is only 2 significant figures, but you can either put this decimal point at the end and then units of aluminum, or alternatively, you can always write the number in scientific notation. 1.10 times 10 to the 1st also shows 3 significant figures. Okay, so either of these would be appropriate or acceptable ways to list the mass of aluminum in your answer. Okay, question 16 is the final question on the review guide. It asks you to convert formula units into grams. So formula units are a type of particle. So like it kind of looks like you're supposed to go from formula units to grams, but you can't go straight from particles to mass. You have to go to the mole. The mole is in the middle. So formula units, 2 moles, and then moles to grams. So you need an equality. Formula units are equal to how many moles, and then because these are particles, this is Avogadro's number, 6.022 times 10 to the 23rd. Formula units are equal to 1 mole. And then separately, how many moles are equal to a certain number of grams? So if you have 1 mole of potassium chloride, you need to add the 2 molar masses together. So potassium is 39.10, and chlorine is 35.45. If you were to add these together, so that's 74.55 grams per mole. That's the molar mass for potassium chloride, which really just means if you have 1 mole, you have 74.55 grams of potassium chloride. Okay, so the third and final step is to set up the multiplication so that the units cancel. So 3.77 times 10 to the 22nd formula units is what we are starting with. And it is asking us to multiply to get rid of units. So we want formula units to cancel. So Avogadro's number with the big number of formula units. And then 1 mole, we already established that it is 74.55 grams. And when you type this into your calculator, almost done, you should get a number 4.6671 with the 3 significant figures that we start with. Your final answer should be 4.67 times, no times, so just 4.67. And then the only units that remain after you have demonstrated that the others cancel are grams. 4.67 grams of potassium chloride should be your final answer. So that is the procedure for how you complete any conversion into grams. If you're dealing with mass, you're going to need the molar mass from the periodic table. This is the one tricky part. The particles to mass needs to use mole as a middle point. So both 15 and 16 are really two-step conversions from particles all the way to grams. Okay, that's it for the review guide. Good luck on your test this unit. If you have any questions, feel free to let me know. Take care.